Hello and welcome to the next video in the Data General debug and restoration series, let's call it, because I am trying to get my microNOVA working. I got this thing pretty much up and running when Usagi Electric was down here, which was an absolute blast. That was just a fantastic, fun, and productive day. That was incredible. But we ran into a bit of a hurdle when it came to the microNOVA itself, which we did get up and running, but we were never able to modify memory. And I have been working on trying to figure out why the memory wasn't working. We read through the manual, we figured out that the bus needs to be terminated. That seemed like a pretty good cause. We terminated the bus, that's not it. We've looked at different jumper configs, software mappings, and all sorts of things, and nothing seems to be working. We cannot use the console debug menu to modify any contents of memory, which should be possible because that's how you would load a program into the machine if you were operating it through the front panel. However, that's not how this machine was run. There's a whole cabinet over there that has drives in it. And it would be really weird and annoying if you had a whole computer system with drives that included a boot floppy and you had to walk over to the machine and manually type in a bootstrap loader. So my suspicion is that in order to get this machine to actually boot and do something that is actually computational and modify memory, it's going to need the floppy drives to be able to work. So today, we're gonna start the restoration process on the dual 8-inch floppy drives for the microNOVA. All right, so this is the cabinet for the microNOVA, and specifically what I'm after here are these. We have two 8-inch floppy drives here, and the one piece of software that I think I have that's maybe good is meant to run on these. And that's why I think that they might be critical to the boot up initialization process for the microNOVA. Now, this is just a hunch. I don't really have a strong indication that this will solve the problem, but kind of running out of ideas for other things to look at. So getting these out and getting the whole drive and its power supply and logic system up and running again is a troubleshooting step, basically just to confirm that the machine itself is working. So let's get these out and start to bring this unit back up to life. This is a Data General 6030 floppy disk set as well, I should mention. I don't know if there are other significant revisions, but some of the ones of these that I've seen online have dial switches here for setting the device code addresses. So you can see one here for this hard drive. I don't know how those are set on these, so that might add a complication to this, but I'm hoping that we'll be able to figure that out once we get it open, look everything over. For now though, I have to get it out, which is not fun. It doesn't retain in the rails, and it's heavy. It's not heavy enough to warrant using the carry cart, but it's not light. There we go. The floppy drive unit for the microNOVA. First thing I want to look at here is the Data General stuff has this like really bad habit of having the door be way bigger than the actual unit itself. So it's scratching on the table and catching, and I'm gonna have to put something under it to make that not a problem. All right, now the first course of action here is going to be disconnecting the two data cables. These are the daisy chain cables that go to the backplane and then to the platter hard drive. So we need to get these out. Everything is already marked inside, or at least it should be from when I initially moved these machines. So I have been in this machine already, and now realizing it's time to start documenting. All right, with that, the front lifts up and it slides forward and away. Oh, the pieces of tape are off. Okay. So we have two connectors here. I don't know if they're actually directly connected or not. I feel like I checked this and they were previously, but this would be the input and this would be the output. And we know that this is the output because it has this extra piece of, it looks like FR2 on here. That acts as a shield for the terminator that can be plugged into here. But what I'm going to first do is just get the cables secured and photographed for how they go in here. That way I can put it back and know exactly what's going on. Lots of pictures. Just document everything out like crazy. Don't want to forget or mix up anything. All right, then this can just slide out the back. And that is where the cables are put into the system. Get them through here safely. There we go. That's freed. I'm not as worried about the power cable. It has a pretty nice grommet bushing bulkhead thing, so it'll be okay. But the rest of this stuff is where this is going to get complicated. And while we're back here, I'll call it, this is actually a model 6039, so that could explain the lack of ID switch dials. Okay, so there are a couple of things that are worth calling out here. One is the just insanely massive PCB here. This goes from this point all the way up to the edge of the machine. It has the front panel indicator lights, has all of the logic ICs. It controls both floppy drive mechanisms here. It is crazy. This thing is enormous. I think we may never have to remove this though, because we have a panel right here, and that seems to contain all of the capacitors for the power supply. So I'm hoping we could just remove a handful of screws here, have this pull out, and then we can work on that stuff. But I think we might be able to work on everything pretty much back here, because this looks like the whole DC power supply system, so it's not going to be too complicated. All it does is give you access to the board. I was kind of hoping the caps were mounted to that. Okay. That's not that useful. Maybe I should look at the... Oh, wait a minute. I'm thinking too small. This is a whole plate that removes and possibly slides out. There we kind of go. Yeah, that was a pain to fight, and I'm not even done yet. There's this giant harness of cables that goes across here for connecting to the DC power and AC power, and I haven't been able to disconnect the AC power cable yet, but I think I can get this unit out of here at least. Yeah, there we go. The problem is the AC power connector is this, and the tabs to release this connector are on the sides next to the giant heavy transformer and the bent piece of metal. So I have no idea how they expect you to actually be able to disconnect that, because you can't get to the retention tabs. So I'm trying to get tweezers into here to press on the tab as I get like this thing and press on it from the side, and I am just having no luck getting this thing out here. All right, I finally got that connector off, and we have just the power supply here. So let's look over what we have. We have one gargantuan transformer here. Over here, we have fingerus chopperus. And then we have 4 big capacitors here. So this one is a 24,000 microfarad 40 volt cap. That one's gonna be fun to reform. That one is a, what brand is that? It might be Nichicon, I don't know. It's difficult to see because this is flat on the bottom, so I'm not sure. Then we have 2 probably Sprague Compulytics. Can't see what they are without removing them, but there's 2 different lengths. And then we have one of the weird caps here. I'm not 100% sure how to handle these. This is rated for something VAC, so we'll have to take a look at that. I think I should probably get some documentation photos here and then start removing these massive capacitors so that we can reform them. All right, I've got the polarities marked and photoed on here, so we're ready to go ahead and remove all of them. Although this first one I say here is connected literally directly to the transformer, so I don't think polarity is going to matter too much on it. So, yeah. The other ones, though, they're definitely going to be DC caps. definitely gonna want to make sure that one's fully discharged. It's got to rub all the way across the bottom to get it out. And then that one's got lugs on it. I don't think I've had a cap with lugs. So it's just got nuts holding it on. Just let me use my wrench to remove a capacitor. Okay. Oh my gosh, I was putting so much pressure on the board, the whole thing leaned forward. And there we are. Wow, that's actually kind of light. Another Sangamo. So, all right. There we are. That's all of the main large capacitors removed. Not even sure there are any small ones on there. Maybe the little tiny ones, but yeah. These 4 here are the main ones that we're gonna be worried about. Yeah, we're not reforming this one. 660 volts. Jeez. All right, I have the cap reforming setup going back over here. We're gonna start out with this little tiny cap here. Lugs are, again, perfectly sized for banana jacks. It's not gonna be true for all of these this time. So this is a 6300 microfarad 20 volt DC cap. So this one's gonna be really easy. I am just gonna go ahead and start the cap reforming process here. I'm gonna go with we'll go with 3 milliamps minimum and a 5 milliamp maximum. So, yep, that's it. It's done. So that took a minute. That took 0 time at all. All right, so we'll pull this one because it's done and ready to go. And then we'll do this one. This one's also 20 volt. Make sure I get these correctly installed. Boom. This one is double the capacitance of the last one. All right, I'm gonna set up the next one. 20 resistor there. We'll go the same. 3 amps minimum, 5 amp maximum, 60, 39, 20 V tall, and there we go. And there we are. That one was also very, very fast. Should be good. I'll let it discharge, and then we will move on to the beast. All right, now for the final one. Here, we're gonna plug this in there, this in there. We're gonna clip, crunch, and then boom. All right, so this is the Sangamo. It is a 40 volt DC cap here. 24,000 microfarads, so that is like way, way more. Actually, that's double the last one, isn't it? It's not that much more. But at a much higher voltage. This one's gonna take a whole lot longer. So 40 volt, 24,000. Let's get that one set up. While that other cap is reforming, we need to solve a problem, and that problem is this capacitor. So this is a 660 volt AC cap that is 2.2 or 2.0 microfarads. This might be some kind of oil-filled paper cap. I'm not 100% sure, but there is a way to potentially test this, and it is one of these. I need to interrupt myself here in this because this capacitor is kind of weird and I'm not 100% sure how to handle it. So I'm going to state up front here that I don't end up actually reforming this in this video, but I think maybe I should have. It's a little confusing. So first off here, this is a General Electric 26F6618FB. We're just zooming in here so you can kind of see what is in front of this, because this is the best picture I got and I didn't take off the band for it. So this is an oil-filled motor start cap, which may not need to be reformed, but I'm not sure. So I was convinced by my viewers live while I was working on this that it didn't need to be reformed, but I started looking them up on, parts sites like Mauser here, and I found motor run capacitors that are listed as having
self-healing properties. Now, self-healing properties are quite literally what reforming is. You just activate the self-healing after the capacitor has been sitting for a while and let it rebuild the dielectric so that it is a safe part to run. And this TDK cap is not the only one that I've found with self-healing. I've found a lot of these with self-healing, including this one, which is a much more generic like air conditioning, HVAC, just random motor one that also lists itself as having, where was it? Self-healing right here, and talking about how it's an oil-filled capacitor, because these other ones don't really mention the oil-filled stuff. But I'm still not really sure. So the closest I've been able to find to a data sheet for this exact capacitor here is this one. So this is a GE capacitor data sheet from the year 2000, and I now have to say the really awful thing. I'm sorry. The year 2000 is closer to 1977 when the microNOVA came out than it is right now. So even though this data sheet is from the year 2000, it's more relevant to the data general than it is to these capacitors on Mouser. Now, this data sheet doesn't mention self-healing or anything like that at all. They're more concerned about whether or not the case is actually painted, which I am not familiar enough with these capacitors to really understand how significant that is for. But this data sheet also doesn't quite make sense, because if we search for the 26F series that this cap is, down here, we'll find that it is listed as a DC cap, which really doesn't make sense. You can see directly on this thing, it lists it as VAC right there. So I don't know how accurate this data sheet is, but this one does not mention self-healing. So I don't know if it was relevant for the capacitor that I found or not. Based on these, I would like to figure out a way to do a reform process on these, but the voltages are obscene. Like I mentioned, here we go. It's barely visible, but 660 volts AC. That's an almost impossible voltage to hit, so I don't know how I would ever be able to reform that. But I would be curious to hear what people in the comments might think about this, unless your comment is that I shouldn't bother reforming caps and I should replace them, because I'm just going to tell you straight up, after reforming all of the capacitors in this thing, I've already been using it for weeks and it's been working fine. So reforming the caps was the right step. You can't tell me they needed to be replaced. So yeah, but I'd be curious to hear what people think about this particular capacitor, because for right now, we're just going to skip ahead to when I gave up on reforming this, because ultimately that condenser checker tester thing I found was a little bit weirder than I thought. It had been modified with some modern caps, and I had to replace the power cable, and it was a little wonky. So yeah, we didn't end up using that thing. It's really cool. Thank you, Wesley, for giving me that, by the way, because that was a channel donation. But yeah, ultimately, we're not going to use that for reforming. So let's just skip on to the next day when I gave up on this, because I spent a lot of time on it, and realized that we can just move on.
I've gone through and I've reformed these three capacitors. This one I've determined is some kind of oil paper weird cap that I can't reform. It's AC, and by can't reform, I mean it doesn't need to be reformed. It doesn't work that way. So that one I didn't even need to remove. These all reformed and passed super duper well, but I'm particularly interested to look at the voltage rail that this one is on after we power this up. I want to say it's going to be 32 volt rail. So I'm really curious, although being for 8-inch floppies, it might be 24 volts, but you know, I'm just curious to see what the rail is on here, because the resulting graph from it noticeably changed at 32 volts, which makes me think that this thing was held at that voltage during operation. So I'm just kind of see for reinforcement of how the whole process works. But this is all done, so we're ready to rebuild the power supply for the 6039 here, and maybe fire it up and get the Nova to actually recognize something. This part's going to be boring because we are just rebuilding the power supply. Okay, this one, I'm gonna just, because this thing rubs against so many parts in here as it gets reassembled. I don't want it to blow anything up. All right, that is the power supply fully reassembled. Everything is ground on that side. And then there's 3 giant bus bars here. You know, there is a power switch on this thing. So I'm gonna have to drag the entire unit over here to actually turn it on. This is gonna spin the floppy motors. There's nothing I can do about it. I think we're ready. I'm gonna do one review of old photos just to try to visually confirm it all looks correct. All the polarities look good. I see no reason not to power this. This sucks because this thing is such a pain in the butt to unplug. I really don't want to plug it back in, but I have no choice. Okay, front panel switch is off. Power strip is off. Power supply is plugged in. The only thing we're going to immediately see is fingerless chopperless turn on there. Other than that, we'll have to break out a multimeter to measure rails. Okay, here we go. Power strip on. Flipping the power switch for the power supply. There the motors go. Oh, those cleaned up well. Oh, that sounds really, really good. So, 8-inch floppy drives constantly spin the motors. Those sound fantastic. This didn't explode. I like that too. We're now gonna do some diagnostics on it before we plug it all back into the logic board here. So we're gonna do some DC voltage measurements here of the power supply just to see how everything is looking here. So I'm gonna turn it on again. Oh, that's so good. Okay. So we have ground here, and then positive on that, 24 volts, okay. Ground here, and positive, 8 volts, okay. Then we have, I have no clue on this one, everything's on the front. 5 volts, looking pretty sweet there, okay. Those are probably the 3 main rails. That's looking good though. So now the actual output rails go here. Measuring those is a little trickier. I don't know how I want to approach that. Actually, change of plans. Before we plug this in, we can get an idea of what the rails are by looking at this connector, and we can check for shorts on the logic board before we apply power to it. And that feels like one of them, you know, probably smart things. So just to double check that I understand ground. Cool. So this is something. Oh, I don't like that. And then this is something. And then this is something. This is 5 volt. We might have a 5 volt rail short. Okay. We're gonna go back to a beep test here real quick. I am putting on my ESD strap for this too. So ground to ground. Yep. And then cap. That's not good. It says 15 ohms.
There was some debate on the stream where I was working on this as to whether or not the 15 ohms was actually a problem. Even Usagi Electric was there, chiming in saying that it was probably fine, but I had never measured a board being that short just from logic ICs before, so it was still really weirding me out. My viewers have been trying to push me for quite some time to use a power supply to power up chips and then use the thermal camera to look for a potential short, so I was thinking maybe this would be the time to do that, but the concern of chips not getting all of the power rails that they need was more concerning to me, and ultimately I just decided to fire the thing up while measuring the 5 volt rail and see what happens.
For kicks here, if I go over So ohms, I am on the 15 volt rail here, so, or the 5 volt rail. So you can see it's a 15 ohm load. So here's what I'm gonna do. The power on the unit is off. The power on the power strip is off. I'm gonna be holding the power strip. If this droops significantly, I'm cutting power as fast as I can. I am also now recording thermal camera footage, and if any one part seems like it's becoming abnormally hot, I'm cutting power. But here we go. We're gonna turn on the whole thing. All right, here we go. It's looking good. Parts are warm. They're not excessively warm. I have 2 right lock LEDs. There's a very high-pitched whine. I think we're good. Okay. Chalk 1 up to learning. I don't know what the high-pitched whine is. It's really bad, though. -5. Okay. So possibly a good thing we didn't power it up. 24.5. Okay. This might be a functional floppy drive. To give you all the fun of it, here it is turning on from the front. There you go. We have the lights there. All the logic does seem to be working. I have 8-inch cleaning discs here. I need to know if I need to use the single-sided or double-sided cleaning discs. So let me try and determine how many heads this thing has. Single head for sure. So we want to use this disc type. So here's what I'm gonna do. It will spin. I don't know how it loads, but I'm just gonna pop this in here after spritzing a little IPA onto it. We're gonna try and clean the drive. I don't know how the head load will work, but this should do something. That goes in weird, man. Ah, there we go. It's flashing ready. I don't know why. Same behavior it looks like over there. All right, look at the dust it deposited on the corners. I do not believe it is pressing down. So this is only clamping the hub motor. So we haven't actually cleaned the heads. But we can't load the heads knowingly without something else. And that something else is the computer. All right, so here we have the floppy drive, the microNOVA, and the dasher. We're gonna try and set this up. So there's one thing that I need to do first here, and I'm gonna have to run around to the back here to show you. This is the terminator that ends the data line. So we're gonna have to pull this off. And this will actually be put onto the main logic board of the floppy drive here. So this goes the other way, I believe here, based on the markings or the orientation of that thing. So we put that there, and then we have this cable. So this goes here. And then the other side goes on to the back plane. All right, now the position on the back plane here, this is just so weird. It just goes at the end right here between 2 cards, and that's it. That's how you plug a floppy drive into a microNOVA. It's the weirdest thing. In theory, that is the floppy drive connected to the microNOVA, and then we have the dasher. The dasher is still only connected to the console debug output, but we're not expecting this to actually try to load anything. My only hope here is that we see it attempt to access a floppy drive. I'm going to put the cleaning disk into the left side drive here in case it just tries to immediately boot something. So we'll see what that does. Other than that, I think we're ready. So I'm gonna turn on the drives. All right. It went straight to console. 2, look. 1, 2. Ah! And there's a fail. Okay, so that's the same behavior. All right, there's one more thing we can try. I'm not crazy thrilled about this, but it's possible it doesn't like the index positioning being wrong. So we could try a real hard sectored 8-inch floppy. The risk here is that I don't know what's on these. I assume it's customer data because I would be the luckiest person on the planet if this was 140 discs of software. That's not gonna happen. Oh, here we go. I like the idea of this one. Bad disc. So that might be our candidate. Okay. All right. Now, I am not expecting this to boot or anything. What I would like to see is how it behaves. Ah, that is different. So we have a solid ready light now. All right, we just got into the console monitor. I'm putting in this disk and I'm gonna try the command 33L to see if it attempts to boot from it. Here we go. I believe that is a no. Well, we probably have the floppy drive up and running now. It needs to be cleaned still, so it's not done, but once I know how to make it spin the discs and load the heads, that should be doable. So it's mostly ready. At the very least, I can power it without concern. So that is a good step, but it did not fix the boot inconsistency. So the next steps are gonna be re-soldering chips and pins and stuff on the CPU card to see where we can go from there, because that seems to be a very sketchy, flaky device. All right, now that we've got this as restored as we can tell for now, I'm gonna go ahead and reassemble this thing so that I can move on to the cards. All right, there we are. So I'm going to put the drive back in the rack for now and take a look at all the cards, but it does appear to be working. So if you enjoyed this look at yet another Data General component that will hopefully be brought to life and function with the microNOVA soon, knock on fake wood, then you may want to subscribe to be notified when I release another video. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time.
Next time on Tech Tangents.
All of these pins here that are gold still were not properly heated up, and the solder is much more likely to have issues.